So the essential question today, how are x-intercepts helpful to graph quadratic functions? So first off, x-intercepts are also known as zeros. To find x-intercepts, we plug a 0 in for y. So to find x-intercepts, we plug a 0 in for y, and then we got to solve. To solve a quadratic equation, we actually have several options. Use the square root method. So factor, square root method, quadratic formula. We also have completing the square. But if we have to complete the square, typically we're going to find the vertex right away. So the graph of a quadratic is a parabola which has symmetry about the axis of symmetry, or reflection. How to graph a quadratic function using the x-intercepts. We're going to find the x-intercepts and plot them immediately. So find the zeros. Since parabolas are symmetrical, the axis of symmetry must be in the middle of them. So recognize to do this, we could average the x-intercepts. And because that axis of symmetry runs through the vertex, we're going to take the x value, or the axis of symmetry number, use it as the x value for the vertex to find the y value. We will then plot the vertex and draw the parabola using the 3 points. So when we find x-intercepts, we're looking for something that's immediately factorable. Intercept form puts something in standard form into factor ready, if that makes sense. So I could either do completing the square to get it in a vertex form, or if it's factorable, I could factor and find the x-intercepts. Let's go. From here, we're going to recognize that this develops a 0 at 5 and a 0 at -1. So we're going to plot the points 5, 0 and the point -1, 0. After that, we're going to immediately put in the axis of symmetry. And the axis of symmetry has to be right in between them. We could average them, taking -1 plus 5 and dividing it by 2. Adding the two numbers and dividing by 2. So 2 is in the middle. You could either look at it geometrically or algebraically. Because that axis of symmetry is at 2, we're going to use that for our x value. Our vertex has to be at 2 comma something. We just don't know what that something is. We got to plug in the 2. Plug in the 2 into the original equation. And use order of operations to find your y value. So once we find this y value, our vertex is at 2, -9, and we plot it. We can use these 3 points as our parabola. Next, we're going to try to find, multiply, add, and in this one we've got a leading coefficient. So we're going to have to keep in mind about bottoms up. So first we set the equation equal to 0, trying to find the zeros, but does anything multiply to -10 add to -2? I'm at a stopping point. So we can't forget completing the square. Or am I just being dumb? Like, does anything multiply to -10 and add to -2? Like, -5 and 2 get a 3. All right, so let's do completing the square. Let's review completing the square. This is just going to be gross. Out of curiosity, what's going to complete the square? We got to take this, divide it by 2, and square it. What are we going to add on both sides? Before you can rewrite, some of you guys on your warm-up, I noticed that we're adding in a 4th after we rewrite, but you can't rewrite until after you add it in. So now I'm going to simplify the left side, rewrite the right side. So we rewrite, and we get the completed square. Let's put it into vertex form. So it looks kind of crazy. Vertex is going to be a little weird. All right, so let's figure this out. We've got our axis of symmetry. It's just at a half, so it's in between here. We've got to find some points. Let's plug in, so T-chart it. Let's plug in some nice points. 1/2, -11 halves. Let's plug in 0 and -1. Plug in 0 and -1. I'm plugging 0 in the first one, so that way I don't have to deal with fractions. So plugging in 0. So once I graph a point, I'm going to map it to the other side. I'm going to plug in -1. So we get this ending parabola. Let's talk about why we could not have factored it. Not only did it not factor, or was it factorable, sometimes these x-intercepts not only, these may not be fractionable, or my bad, rational. They could be irrational x-intercepts. Can't forget completing the square. This was ugly. This will never be on your test, but at least we did it together so you know what to do-ish. All right, let's go to the next one. So the question about this is can we factor? The bad thing is they don't have a greatest common factor. So maybe factoring isn't it. What else could there be? It's like a trick lesson today. It's a trick lesson. The topic was how do we use x-intercepts to graph? But no, wait, that's the essential questions. How to use x-intercepts to graph? We could use the square root method if factoring doesn't work. So let's find the zeros. Let's add 10 to both sides. So when we find the zeros, now we've got to put this in our calculator and figure out the approximations. Where's the approximations at? That's where I'm crossing the x-axis. So now we got to figure out where, wait, the axis of symmetry runs right between them. So let's draw the axis of symmetry between them. So the vertex will be 0, something. You plug it into the original. Let's figure it out. Graph the point. Connect your points. So so whether we use square root method, factoring method, or whatever from the previous one, I just realized this. We could have done quadratic formula. Whoa. And we didn't. We could have found the x-intercepts using quadratic formula. I have a feeling they would have either came out to be fractions, or it would have happened to be some sort of radical or irrational thing. Ooh, that probably would have been a lot better than the completing the square strategy. Whoops! All right, so let's go to 4, if you haven't done it already. Let's try to figure out what to do here. They share a greatest common factor. Let's pull out a -6 and an x. They both share a -6 and they both share an x. They also both share a +6 and an x. Either way. We get the following zeros. So this x is going to be 0. This x minus 4 develops a 4. We're going to graph those x-intercepts and find the axis of symmetry. The axis of symmetry is going to be right in between them. So the vertex is going to be 2, something. So we get some sort of crazy vertex. Either we could add in, 14 more thingies, more tick marks, but I'm not going to do that. I could also change my indices. So after we change the indices, shabam, shabam. Try to make your parabolas look a little bit more U-y, not V-y. So in this homework, you're going to be given intercept-ready equations. And what I want you to do is immediately find the x-intercepts, find where your vertex is, and connect your points. 4 problems.